Live. This evening, we're going to play with a video game. Well, actually, I don't know what you'd call it. It's definitely a Steam game called SHENZHEN IO. I am not new to this game, but I felt from the first time I saw it, it was just amazing. So I've sent a copy of this to several of you, and we're going to dig into SHENZHEN IO. So with no further ado, let me introduce the first page so that you understand basically how to start playing it. The on-off button in the top right-hand corner executes the game. And that's the thing. Is this a game or is this actually a sneaky way to teach you Alta3 teaches assembler? I'm not sure which, but we don't want to click that button up there. Solitaire, we're not going to touch. The control panel is the classic control panel to turn features on and off, turn the sound off, which is definitely what I want right here. I don't want music playing, so that's got to go. The data sheets, this is absolutely mandatory. You cannot play the game without this. So when you click on this, in fact, I think this is so important. Let me just go full screen on this so we can actually take a look at read the manual. You got to RTM it or you're not ever going to succeed in this game. Which is like amazing that this is a game that I have to read the manual. And if you don't read the manual, you're not going to beat this game. It's as simple as that. It's really well done, and it's not trivial. There's like 47 slides or pages in here. It's really well written, and if you take the time to actually read it, it's kind of humorous. It does not include everything. Part of the game actually includes some undocumented things, and it turns out that your boss, who is Chinese, was going to tell you that, well, some of the things that these microprocessors do hasn't been converted from Chinese to English. And of course, you get all miffed at it. Your player gets miffed at it as you realize that one command would have eliminated like a dozen lines of code. All right, so read the manual. That's the first thing you're going to have to do. Next thing, the game is actually played by clicking the concept mail. So we're going to click the concept mail. And here we get our first assignment. Now you can see I played this years ago, but I'm just going to go right through the game. And you play the entire game from your email inbox. So here's your welcome. And just for the sheer entertainment of it, read this stuff when you play the game. Here is Carl. He's sort of like your supervisor. So he's acting just like you, quite frankly. Fresh meat. Just kidding. Welcome to Southern China. And he goes into all the details. Here, this guy right here is Joe is the product manager kind of guy. Ray, okay, we keep on going. You can read all this stuff. And right here's your boss on the very bottom. Hello. I'm the chief engineer, your boss, and I've not managed many foreign workers, so please understand if I make any mistakes there. Anyhow, welcome to your new game. So, all right, step 2, I already gave you the speech. Just like in real life, read the manual. I've always said that one of the things that Alta3 does, emphasis on research, Alta3 is we read the manual. It's what we have to do. So I'm going to save you from having to read the manual. I'm going to take you into a security camera. And let's just go ahead and go right into it. I actually have 3 designs here ready to go. So huge spoiler alert. I'm going to actually solve this one for you because I'm interested in you understanding how it works. And once I've gone through these 3 designs, that's the end of this presentation, at least the formal explanation of how to use the tool. Then if we really like this, next week we're going to try this again, and we're all going to see what designs we come up with for step 2. But the fake surveillance camera is pretty straightforward. So let me just take you straight into this one. So on the right-hand side, you see a lot of electronics components, mostly DIPs, dual inline pins, that are designed to actually plug into a circuit board. The game will force the circuit board design into this, because if you consider that you're going to fit this into a camera, then you don't get to change the size of the circuit board. Like, welcome to my world. When you're designing something that has to go into a certain, then that's what it gets, and here's the size of the chip. Now, why don't I start with a brand new one? And the reason for that is there's some things about the game that are really frustrating, at least for new people, is how do I get this off? Because I don't want this. I want to get rid of this. If you'll notice, if you look very closely at my cursor moving around the screen, when I get above this little thing, it changes. When I go over here, it turns into some kind of a little flower thing. You can grab the chip and just throw it over here. I didn't throw it far enough. Now I have to go in. Yeah, I'm glad this happened. Bring it back out of full screen. And I want to drop it over here. It's not going to let me get rid of it right now because it's programmed. I think what I'd have to do is clear it. And then I could rip it off the screen and start again. The instructions on how to build this camera require that I fit the entire logic on just these two cards. So I'm going to tell you that your solution is going to look something like this. Actually, why don't I just slide that over one step farther? And I'm going to connect this input by just dragging like that. Now I have these two microprocessors. These are the MC4000s lined up that are ready to run code. So you see the MOV, that's move. Then the operand would be the value of 0. That would be an integer. And then the P0 would be this particular output, P0. So move the value 0 to P0. SLP, that opcode means sleep. So this is going to sleep for 6 pulses, then move 100. So 100 means full power. So you can go from 0 to 100 to P0 and then sleep for 6. So just looking at this, I could actually watch what the output looks like. Now here's the output that I'm supposed to create. The top board is supposed to create the active light. The bottom board is the network. So if you read the email that introduces this, the boss told us that we're building a fake video camera, and we're just going to blink the lights that it looks like it's actually alive and clicking. So what you're going to want to do is hit the single step. So if I click the single step, notice that the state says execution, and the accumulator, that is known as a register that you find on a chip where the results of the previous mathematics were accumulated. This is a mind-bendingly fast, tiny little chunk of memory that runs in almost the 0.5 terabit per second rate. Unbelievable how fast things go inside the CPU, which is where you're at right now. So the first step is execute. Execute means pull the opcode in this case, move, and figure out what I'm supposed to do. And the chip said, oh, I'm supposed to move. And then it'll act on the operand, which is the value of 0 to the output P0. So if I do the next step, I sucked up 1 unit of power, and the accumulator now says 0. That makes sense. Step. It's not going to sleep for 1. Now, you would probably have to look on your screen, but you'll notice down here where my cursor's moving across, you see things called clock cycles. So we are in the beginning of the second clock cycle, and we're going to sleep for a total of 6 of those. So if you just see, you'll see 1, 2, 3, 4, 5, 6, and then we see the rising edge. The rising edge is the beginning of a square wave. The trailing edge, believe it or not, is the end of it. This stuff isn't that complicated, really. So, and because we're really running in binary mode, then that means we're at 0, and then we go to 100, and then we drop back to 0. The least expensive electronics you can possibly create are either on or off. And this is by a magnitude cheaper, millions of times cheaper, if all we do is on and off. Now, you can go anywhere in the middle, but when you get different grades inside of there, you're jacking the price of things up significantly. All right, so let's just keep stepping through this. So we're on sleep number 6, and we keep on going, and it pulses. Hey, looks like this is working. So I'm just going to go ahead and simulate it and watch it right through. And so it looks like this is working. So what this is actually wanting me to do is to learn from this example right here and then copy the code basically down here to do the next one. Well, in the process of, hey, why don't I just keep this clicking along? Let me show you my first design that I came up with when BJ first gave me this game. So the code was just fine up here. It was doing everything it needed to, but I had to write this. And if I step it through, it'll just work. So I'm going to go ahead and emulate it. You see the camera blinking. I'm watching it go all the way across here. I'm thinking, hey, I think I have product. Ship it. It's good. As soon as you do this, the boss sends an email. Congratulations. We're gonna build that right away. Meanwhile, you look against like the rest of the world, and if your little line is to the right of the median, then you did it, but you didn't do it as well as a whole lot of other people did. So in fact, I'm thinking, I'm using a lot of power in this example, and I have a lot more lines of code right now in this example. So I'm returning back to say, okay, he said, thanks for your prompt work. The blinking light works okay. But I said, you know what? Give me another shot at this. I have 13 lines of code and 63 power. What if I do a power optimize? I'm going to get that 63 power down to 57 power. So let's take a look at that one. Well, first of all, you'll notice that there is this, and in fact, that's probably a poor choice. I should probably go to this one because it only has 3 lines of code, and I can teach some additional components. In a rather humorous email, which is a spoiler alert, it comes along later in the game, you're told that, oh, by the way, there's a special opcode that we never told you about. It's called generate, and then you specify the output, which is P0, and then this is on 6 clocks, off 6 clocks. And the dialogue on that was really funny. But there's one problem with this code. In fact, if I yank these guys out of here, you're going to see right away what goes wrong on this one. So let me just run the simulation. See if you can spot it. What happened, guys?
The signal's inverted from what it should be.
Yeah, it's exactly the wrong way. And I see that if I step through it. So what I need to do then is kill this, break that, which I'm just right-clicking it is all I'm doing. And I'm going to grab an inverter. So this little nifty thing right here, which is probably always a good idea to use that anyhow. The little dot on the end means if I get a 1 in here, I'm going to invert it and send the opposite out. So if a 1 comes in, I send out 100. If 100 comes in, I send out 1. If it's anywhere in between, this is a very valuable thing of an inverter. If you send a 20 into me, that's 0. If you send a 60 into me, I'm going to freshen that up to 100. Do you get it, guys? Now, there is an element of purity in what I just told you, because as signal goes down a wire, it deteriorates. It's like sending an ice cube down the wire and it starts to melt. And it's only a 60. It started out on 100, but it's just 60. But this little chip right here knows what an ice cube looks like. I said, you're a 60. I'm going to boom you back up to a 100. And you get a really crisp basically rejuvenation of the signal. Now, this did add cost to our design. So, but the boss doesn't care what it costs. He doesn't care how much power it uses. He just wants to ship. So if I drop these inverters in and now I run the simulation, I have now come up with pretty much the universal solution for, I think this is as good as you can go on this one, guys. This is fully optimized code, and we have reduced the line of code down to 3. That's the best. No one is able to beat this and all of the people that played the game. So we're doing pretty good on this one. Let's return back to this email, and I'm going to show you the final optimization, and then we're going to call it quits on this one. And we'll see, we'll quickly discuss the merits of this approach. So I want to reduce power. And I have to admit, I was a little disappointed at this solution. If you simulate all the way to the end, what you're going to notice is that the active signal on the top, if you go all the way to the end, never returns to 0. So by not executing that last gen, you save 1 step of power. So what happens is when it gets to the very end, instead of requiring 58 power, it requires 57. It's a game. We're playing fun with it, right? But this @ sign up here means execute only once. Interesting thing about the MC4000 chip is that whatever code you put in here, it just repeats over and over and over and over again. It automatically goes to the top and it just loops. That's a really, we would have killed for chips back in the 80s that made it this simple. But and it's what it does. So you're like borderline programmable logic arrays, what you're doing, but this is definitely a processor. Now, so what does the little what's that little decorator do right there? That says, don't execute me the second time. Just run me once. So this is basically straight through code that quits. And because it uses 1 unit less power, because I'm not doing that gen opcode right there, I actually score a 57 power instead of a 58. And that's how you beat that one, which I thought, yuck, that's terrible. But that is the solution for the security camera, that fake camera. Now, the next one, which I'm challenging you for next week, is the replacement factory module. So you would click on this, and the first thing that you would do is you read down through this. I know I owe a couple of you guys a SHENZHEN IO. It's coming. And you're going to do this replacement factory module, whatever that is. And he says the appropriate, or he said the previous one was smashed. Smashed! Hang on a second. What happened? Is everyone okay? No need to worry. Oh man! If you don't read the little comments here, you're going to miss out on this game. Maybe it's because I just came from that era or something like that. But click on in and start the design. So I was playing around with a few different designs, and I actually have the power optimized down pretty well. Down to 3 lines and 133 power. There might be some more opportunity. In fact, if I click on, I'm in the production cost. I'm in the hunt. I'm probably good enough, I'd say, because here's the design I have right now. Just ship it, and I would ship it means I think I did good enough in this lab. I want to go to the next one. But this is taking labs to the ultimate. All right, let me go ahead and stop the screen share and get your comments on this approach. What do you think of this one, guys?
Yeah, it looks like a fun way to learn if that's what you're asking.
Yeah. The thing is, this is actually real. What this is doing is these are the $1 million development platforms that you actually developed on back in the 80s. That it's phenomenal. To this day, that at this level, the chips still work like this. it forces you, as you continue to move through, to solve problems on the bit level.
Yeah, I mean, it's Microsoft Flight Simulator, effectively.
Yeah, it is. It's definitely what it is. With some window dressing or some funny dialogue, they tried to add some story to it. But ultimately, I think what's probably interesting is there is a competition, or there was when this game was really hot, that everyone wanted to get the best design. They wanted, and I think what probably made SHENZHEN IO slow down was that pretty much the designs have been optimized, and the people that just live for that sort of thing. Yeah. So just be aware there are in the design thing. There's a lot of other components down the side here that I didn't cover with you at all, that actually are extremely fundamental in the way that all modern processing works. And I think that would be fun. Here, let me show you what I'm talking about. Is down the side of the screen, there's a lot of other components here that I think you could learn a ton from just seeing how they work. All right. Any other comments?
No, I look forward to playing it.
Thanks for giving me an excuse to tell my wife, hey, I need to go play video games.
That's right.
I'm not.
Yeah. Alta3 Research, the only place that we send you a Steam game. See you next time, guys.
Peace.
So yeah, thanks, Stu.
See ya.